So as you're reading this problem, there are a lot of things going on in this one. So big question is, how many peanuts does it take? So we're boiling a cup of water, assuming that the water is initially at 20 degrees and all of it vaporizes. We have some information about peanut oil and carbohydrate percentages in a peanut, and we're considering the peanut oil is palmitic acid, and carbohydrate is going to be a starch. So average peanut has a mass of 0.73 grams, and an 8-ounce cup of water has a mass of 237 grams. We have heat of formations given for the starch and palmitic acid, so lots and lots of things going on in this. So first thing you might think of is figuring out kind of how much heat does it take to boil that water. So that might be the first thing. So amount of heat to boil the water needs to be figured out. Okay, the balanced equations. For the starch and the oil. The moles and the peanuts. And there's got to be something going on with these heats of formation. So why are these delta H values of formations given? So if we start with any one piece, so you can start with order really doesn't matter, but if we're looking at the heat concentration, we're going to start maybe with that. So first thing I might look at is the water boils at 100 degrees. I'm starting at 20. So I have this diagram to deal with. Okay, I have this mass, so Q equals Cm delta T for this portion of the temperature change plus delta H vap times M. So just substituting what I know, 4.18 joules per gram degrees Celsius times 237 grams times 80. So again, that's going from 100 degrees down to 20 degrees. Plus 40.7, so this is coming from previous worksheet. So I've got to kind of figure out this one. 237 grams. So I've got to get the molar mass in here. 1 mole, 18.02 grams. Sorry, that's an 8. Okay. And when you calculate all of that, you're going to get a total of 615 kilojoules. So this one's in kilojoules, so this has to also be kilojoules. And again, you don't really have to show metric relationships, but you do need to figure out where they're coming from. So that's the first piece that we need to take a look at. So the next thing that I'm going to probably deal with is all of this stuff about the peanut. So we have this 49% and this 21%, so I'm going to look at those amounts. So I have 0.73 grams of peanuts times 0.49. I'm just converting the percentage to a decimal times 1 mole over 256.48. And again, that's using palmitic acid's formula here, which is 1.4. Sorry, I'm not sure why my decimals don't show up on this. Times 10 to the negative third of the C16 H32O2. Okay, and I'm going to do the 0.73 grams times the 0.21 times 1 mole over 162.16 grams. So that's going to be my carbohydrate molar mass. And that's going to be 9.5 times 10 to the negative fourth moles of starch. Okay. So my next step is going to be to write balanced equations for these reactions. So for the palmitic acid, we're going to be burning these. So since it's burning, it's going to be combustion. So I'm going to add oxygen, and I'm going to get carbon dioxide and water out of those. And again, they're all carbon-based, so you're going to get the same thing for both of them. And then it's just a matter of balancing your equations. So I know you want to know how to balance equations, so I'm not going to go through the steps of that. So we're going to have 16 CO2s, 16 waters, which is going to give us 23 O2s. For that equation, I'm going to need 6 CO2s, 5 H2Os, and that's going to require 6 oxygens to balance that equation. So the reason I need the balanced equations is to do the Heaps of reaction. So remember, that is the summation of the products minus the reactants. So 16 moles of CO2. Again, you'd be getting the negative 393.5 kilojoules per mole. It's going to be coming from the back of the book, plus 16 moles times the negative 241.826 kilojoules per mole for water. Okay, minus 23 times 0 for oxygen, plus 1 mole times the heat of formation of the palmitic acid, which is negative 124.18 kilojoules per mole. And when you solve that, you get negative 1.004 times 10 to the 4th kilojoules for every 1 mole of palmitic acid. We're going to go through the same procedure for the starch. So for the starch, again, using the equation for the balanced equation, I'm going to have 6 moles of CO2 times that negative 393.5 kilojoules per mole again, plus 5 moles times that negative 241.86 kilojoules per mole for water, Again, sum that for the products minus our reactants. We're going to have 6 moles times 0 for the oxygen, plus 1 mole times the value, which is now 734 kilojoules per mole of starch, and when you add that all together, you get negative 2.83 6 times 10 to the third kilojoules. Okay, so next I'm going to have to factor in the kilojoules per mole of substance versus how much substance I have. So your heat is going to equal 1.4 times 10 to the negative third moles times the negative 1.004 times 10 to the fourth kilojoules plus 9.5 times 10 to the minus fourth moles times negative 2.836 times 10 to the third. And that is going to be negative 17 kilojoules per peanut. And if we go back to our original heat value, so we need 615 kilojoules to boil that water. And you can't have negative peanuts, so it's just going to be 17 kilojoules per peanut for a total of 36 peanuts. So my dear students, if you can get through that problem, you can solve a lot of heat problems because it has a lot of concepts in it. Okay, so there's a problem set there. They will not be as complicated as these, but there should be some problems to challenge you there as well.